Okay, thank you again. I am Julen Astudillo. I work in Tecnalia. Tecnalia is a research center of Spain, and what we want here is to give you a brief explanation of a project that we have coordinated for the Horizon 2020 call that wants to mix robotics and construction. So the name of the project is HEPHAESTUS. And what I'm going to give you is a brief overview of what we have done on the project. So this is more or less where I'm going to talk in the presentation. So the general overview of the project, and then to focus on the results that we obtained during the 4 years that we last working in the project. So why this project? So 5 years ago, there is some calls from the European Commission in the Horizon 2020 framework program trying to look for more sectors that can use robotics. So once we analyze this call, and also with some of the partners that we have in the project, in this case the University of Munich, what we think is what can happen if we try to mix robotics and construction in order to see what can be done there. Because, as we know, construction sector at the end has some problems. Robotics are being used in some way, but a lot of work have to be done there. And also, as our team is expert in the field of facade, what we think is, can we try to see what can be done if we install a facade using a robotic system? And this is the starting point of the project. So what we propose is to use a cable robot, a cable-driven robot. You are going to see in the next slides what I am talking about. Is because at the end we want to focus on site. So this is not something to be done on the factory. It's going to be done in the building. So where we are going to have all the problems. So the thing that we have with the cable-driven robot is that we can move elements and move across big environments. So we are not focused to a specific place. In fact, the results that we obtain is that we can move elements in a matrix of 100 by 100 meters. So the components that we have in the project or in the system is a cable-driven robot that we are going to use to move across the space, and what we call a modular end effector that is going to be the robotic element that make the different activities that has to be done in order to install a facade. And what we want to mention is also that we have a system that is multifunctional. So what we are going to perform different activities, because these are the activities that have to be performed once you want to install a facade. So what we are going to do is to install these prefabricated panels of the curtain walls. We can replace damaged elements. So at the end, once the building is finished, the system could remain in the building to make replacement or to make the maintenance. So this is something that can be done. What we want is to have a system that is easy to move, not have problems related to that, and have compatibility with other systems that we can have in the building, like gondolas, scaffoldings, all typical platforms that we have in the construction. So these compatibility issues has been checked during the project. And also what we want is, because of the cable, to have a system with high versatility and with a reachability very broad. And also to be able to be moved across complex geometries. Also, a controlling system has been developed, and what we need is an easy and fast calibration because we are going to change from different parts of the building each time. So, as I mentioned, the project is a project financed by the European Commission. It's a project of 42 months. At the end, it's 48 because of the COVID, and he ended on December of the last year. We have 9 partners, 3 SMEs. So BCNI, which is a company that manufactures cranes, R2M that help us in the business and dissemination issues, and Enlink, which is a Norway company that develop robotic solutions to make different works in construction. Also, we have two large companies, Acciona, a Spanish construction company, a large company that manufacture and build different kind of buildings, and Foci, an Italian company that install facades. And also we have four research centers, Fraunhofer, Tecnalia, LIRM, and the University of Munich that help in all the issues related to the specific research. So what we build with this consortium is to have the entire value chains of construction and robotics in order to be able to manufacture, or at the end be able to check if the system that we thought initially was able to be done. Related to the progress of the project, related to the technology readiness level, so the cable drone started in a validate. Well, once we started, we have the robot in a lab environment, and at the end we reach the building, the manufacturability of the full equipment. And the other system, the end effector and the controlling system, at the end started in the same point, and we reach a little low, but more or less we check the at pilot production is demonstrated, as you are going to see in the next slides. And we have 5 companies to make profit. We are going to have one demo building in order to check that everything works properly, and one of the main objectives at the beginning of the project is the high flexibility of the system. So, more or less, this is the work that we are performing in the project. It started with the specification, then the design of the system, the demonstration at laboratory level and at virtual level, and also we have, again, as the companies want to make profit, the business analyze in order to see how we can include this system in the market. So here we can see the 2 demos that we performed in the project, the one in the left in our laboratories in the Basque Country, and the one in the right in a structure that was built by Acciona in close to Madrid. So the different components that we have is, we have some winches that host the structure, the building in this case, that we use as a demo. We have the components of that support the cables in the upper part of the building and in the bottom part. You can see here in our Tecnalia lab, and also here in the Acciona demo building. And also we have the platform, which is the robot that moves across the space and that hosts the different technologies that we use to install the facades. And inside this platform, we have the 2 modular end effectors that we have in the project. And obviously, we have different sensing and control devices because we need a high level of accuracy in order to perform this activity, around 1-2 millimeters, in order to be able to install these facades, and take into account that we are talking of a demo of 12 by 12 meters and a construction possibility that of a building completely. So one of the main issues that we have is the accuracy of the entire system, as we are moving big weights. So take into account that the platform weighs around 300-400 kilograms, and each of the modules weigh more or less the same, so 300-400 kilograms. So we are moving this type of loads. What we have as the end effector 1 is the system that we use to install, to put here we have some elements to connect to the slab. Then we have where we put the anchorages that are going to be installed in the slab. This is one of the anchorages that we have here. Also, we have the different tools in order to make the holes, collect the anchorages, and screw the bolts that we have. You are going to see this in the next activity. And also, you can see here one of the modules that we move in the Tecnalia lab. Is a module of 4 meters high, 1.5 meters width. So we have here a vacuum, the module itself, the vacuum system, the equipment to make the vacuum, and the control system, because everything is controlled by a software. And here, as we don't want to always say the good things about this project, this is something that happens if you fail with the control. So we have, if you can see here, the cables are not tension. This structure, as I mentioned before, is 400 kilograms, and we have a problem with one of the controllers, and at the end, we have this problem that we lose the tension, and it provokes a rotation of the platform. And okay, we have luck, and nothing more happen. But this is the type of things that happens when you make research, and okay, you are moving big loads in a big environment. So safety issues are quite important, and okay, this is something that could happen once you are making this type of research. And I'm going to show you a video with the results. So I'm going to put, and I'm going to comment. So this is the final demo. You can see how the platform can move. First, the activities that we have at Tecnalia. So which are the components, as I mentioned. This is the cable robot that can be moved across the entire space. We have some elements to control the system and to connect to the software, the winches, and the routing elements that we use to move the cables, and the sensors that we have on these cables in order to check that the tensions that are a quite important element we need to know. And here you can see a brief overview of how we install one of these anchorages. So we connect to the slab, we make the holes, we collect the anchorage, we put the anchorage, we collect the bolts, and we screw the bolts. This is something that is made automatically by the system. So we have a BIM model of the building. The system knows where he has to install the anchorage and then install them. Then it can collect the curtain wall automatically with these suction cups. It detects where the curtain wall is. Okay, we have people controlling that everything works properly. We have electrical components. The system of control is based on backoff, and we have an interface and a manual mode if something happens. So you can also, we have a total station in order to increase the accuracy of the system, and you can see, and now we are going to see the final work as we have done in Acciona demo facilities. The day of the video was quite foggy, but okay, I think that you are going to be able to see the different system. And here we see the complete process of installing a bracket. So the robot comes to the space, to the place where it's going to install the anchorage, make the holes. You can see that we are talking about concrete. It cleaned the dust that we have, put the anchorage where we put collect the bolts and put the bolts on its place and screw the bolts. Once this is done, collect the tool, leave, and finish. So this is something that we need to do many times on the slab, and then the next activity is to collect the curtain wall. So we use the vacuum system, we move the curtain wall until the position defined by the BIM model. And as you can see here, we need to install this curtain wall with this type of anchorage in these elements that we have. And this type of facade, that is a glass facade, we need to perform this activity many times in order to repeat. All this information is included in the system of the project. And okay, we can do with only 2 persons controlling that everything is okay. One in the control room that we have, and the other one close to the demo, close to the final position, in order to check that everything works properly. So and to finish with the conclusion, so what we obtained in this project. So we validated the possibility of using robotics in the construction sector and to install facades. So this is something that is proved by the project. And which is the added value? Because, okay, we cannot use robotics because it is interesting. We are going to use because it changed something, it improved something. So we improved the time of installing facades. So we reduced the time of installation in a 50%. And also we increased the quality of the installation. One thing good about robotics is that they perform every time the activity in the same way. So you don't have problems of repeatability, and this type of systems, what needs is repeatability. So if you perform the activity one time good, it's going to happen that almost all the times it's going to be well done. Safety. Related to construction, this is something quite important. The system increases the safety of the workers because you don't need to be close to the edge of the slab. You can be in a control room, you can be in the floor some meters away, so you don't have any problem because of a heat of the system that sometimes happen. So this is something important again. And related to the cost. So the cost of the system is the same that some of the elements that we have in buildings like crane or gondolas that are using for cleaning or maintenance at the end. So you can have this system at the same value that you have other elements in the building. And this one has more flexibility because it can be used during the construction site, but also during the maintenance or the life of the building. So which are the next steps? At the end, robots need to increase flexibility. So at the end, we need to be able to change or to adapt to new conditions. And this is something that at the end needs another tools like artificial intelligence or other elements. We need to improve the perception of the environment. At the end, the robot needs to know quite well where it is, which happens at the surrounding, and this is something that we check that has to be improved. And also, okay, as this is an ongoing work, we are going to include in this system additional tools for cleaning, maintenance, painting, whatever can be needed. And to finish, okay, also this is something important to apply to renovation, as this is one of the main issues that we have in Europe at this moment. So the construction sector needs to face with new construction, but also with renovation, which has more problems than the new construction. And this project that I explained is focused on new construction, and we are starting to manage a new project on the Horizon 2020, on the Horizon Europe proposal, in order to apply the system that we have shown you to the renovation of facade. This is an ongoing process where we are. And more or less, this is all from my side. Thank you. And any comment, please tell us.